Okay, this is about to become the Tsvwg meeting. If that was not your intended destination, you might want to catch another flight. All right, I think we want that one. All right. No problem. Thank you very much. Greetings. Thank you very much. All right, I gotta go find here. All righty. Okay, could somebody shut the doors back of the room, please? Andrew, we're starting. You can come in or stay out. Okay, we get the bigger room for the shorter session. Welcome back to the Transport Area Working Group. I need a volunteer or two to take notes, please. Okay, name? Vincent, thank you. Did it for the last session. I need one more person to take notes. That way we can double check. And Maxime, and you're a speaker, but we know what you're going to say. We've got your slides. Okay, great. Thank you. Okay. Cool. All righty. Okay. This is the note well. It applies to this session as it applies to every other session at the IETF. This is the, I've got the right, whoops, no, I've got the wrong slide deck. Hang on. No, I've got the right slide deck. I'm not paying attention this morning. Document review reminder. In particular, I need to say something about this in a minute. So here's Jennifer Wednesday starting the agenda review. We have 4 SCTP drafts. Some of these are just status reports. Don't blink. They're going to go by fairly quickly. Some of them have slightly longer discussion. And then we have 2 individual drafts. I get to try to channel Joe Touch to talk about transport options for UDP. And then Vincent Roca is going to talk about version 2 of the forward error correction framework. And I guess I'll be taking frantic notes during that talk since he's one of the note takers. Okay, we have the usual warning for speakers. Where is it? Oh yeah, there it is. There's a pink box here. Please stand in the pink box. It helps the remote participants. Okay. Randy Stewart, did you make it? All right, we will bash the agenda on the fly. Max, you want to go come do 4960 errata? And I can do Randy's slides if I have to. I don't think there's a whole lot to be said there. And let's see if I can, if I get really good, I'll actually have a remote for you. How about that?
Okay, hello, my name is Maxim and I'm here to present you the last status of the draft called RFC 4960 errata and issues. So basically what the idea of this draft is that we are describing issues found since the publication of RFC 4960, which is the specification of SCTP. We describe issues, solutions for them, and exact text how we want to address them in the second draft, RFC 4960B. So this draft is kind of prerequisite for this document.
Okay.
So what actually happened since IETF 96? First of all, the draft was adopted as a workgroup draft, and we published a document with a slightly different name. The current revision is 01, and it already addresses 40 issues. Since IETF 96, we described 6 new issues. And in our list, we have currently 14 open issues, but I think that 9 or 10 of them should be actually addressed. Yeah, we use issue tracker and in GitHub, so all the issues, all revisions of the draft, and some of the discussions are there. It's public, and anyone can go there and publish issues. So what we still need to do is, we still have remaining issues and we need to address them. If there are some new issues, we will work on them. Actually, we have some issues, some external issues, I mean, not only published by co-authors of this draft. So anyone is welcome to publish issues and we will look at them. And we also want to get feedback on this draft because now it's a working group draft. We want some reviews, and we will appreciate if you send us comments on this draft. Yeah, that's basically what I wanted to say.
Let's see. So are any of the issues significant and likely to require attention by the working group, or is are these turning out to be issues that the author team that knows SCTP well can work through and propose reasonable resolutions for?
Well, majority of the issues are clarifications or some editorial stuff or removal some inconsistent things. But there are a few technical issues. So yeah, I think that it would be really good if you look at this document
and if nothing else, bring open technical issues to the meeting, the meeting in Chicago. I think we basically decided that this draft's going to need 2 meeting cycles. That we're probably not going to be done with it until the until the second meeting next year. I'm looking at one of the ADs who probably knows where it is because I don't remember where we're going after Chicago.
Okay.
Okay. So. Anybody's interested in SCTP, please read this draft. This is the kind of nitpicking details that are necessary to get the implementations right and make sure they work together. Any questions for Max? I'm sorry, is it Max or Maxine? Do you care?
Yeah, just to know that we have a few reviewers. I mean, some offline discussions, and yeah, I think that at least we know a few names who volunteered to review it.
Yeah, we know we know who some of the usual suspects are. Okay, thank you very much.
Thank you.
Okay, Randy. Well, you and the ADs have just run an experiment for us. All 3 of you have proven that 10 minutes is insufficient time between meetings. Spencer, you can please take this back to the IESG's end of week wrap-up meeting. And Randy, you're up next. Let me go get your slides. And while Randy's coming up here, I need to announce a correction to something that happened yesterday. The lower effort PHB draft, I wasn't paying enough attention. It is already a working group draft. However, it only just made it in under the correct name to become a working group draft. So we don't need to run an adoption call on it, but we will be looking for people. Please read this because this lower effort service, also known as scavenger or less than best effort, is becoming something that people would increasingly like to see in DiffServ, and that draft is going to be the vehicle for actually specifying it in a fashion that we think we can use. So I apologize for goofing that, but the good news is I have 1 less adoption call to run on the list. Okay, Randy, okay. And with luck that remote works.
Okay, so stream scheduler and user interface interleaving for SCTP. Basically, we've had a few minor clarifications that Gory had us put in. There's been no technical changes. As far as we're concerned, it's ready for a working last call. So you could start that after the meeting, maybe.
Yeah, we probably will, because this draft has the dubious honor of being the last TSVG draft in the WebRTC hairball or tarball or whatever you call it. I would not like to be the last draft standing in that one. So we will probably last call it in the fairly near future, with the goal of getting that out of here and getting out of the way of whatever's going to happen in WebRTC.
And as far as implementation status, we have there's a simulation Omninet that has it in it, as well as the FreeBSD stack, which is also all in the user space, has this code in it. It's working. So it's we kind of move slow because we actually do code for everything. So but it gets there.
It's so nice to have stuff that works.
Yeah, that's always a good idea. Next draft is the NAT support. This has been around for a long time. There haven't been any changes since the last IETF. There's it sounds like Michael has a VBox implementation he started. There is actually a previous implementation in FreeBSD of this, of a past version of this draft that's been out in the firewall / NAT of FreeBSD for quite a while. It may need some updates, I'm not sure. There are still some things to do. I think this draft split and merged and split, and in the process, some of the text need to be shuffled around so that you have NAT implementation points and endpoint implementation points all in correct places. And of course, there's some issues with covering the IPv4 to 6 and vice versa translation, but they're all things to do.
Okay, and this one we're hoping, when we talked about schedule yesterday, hoping that this will move in the next meeting cycle, and we'll be looking at working group last call resolved in Chicago, in Chicago, and we'll have moving onward. Okay, I need to ask a tangentially related question. There is a carrier grade Nat Yang draft looking for a home. Raise your hand if you're familiar with how Nats work. Keep it up if you think you understand carrier grade Nats. All right, we aren't completely clueless, but Spencer, I think you have some useful information.
Thank you. Final SCTP draft is UDP encapsulation of SCTP packets, additional considerations. There have been many changes here. Explicitly describes handling of embedded addresses in inits and inacts, and it's going to transform into 6951 bits, which is the original UDP encapsulation draft.
Okay, so this will turn into 6951 bits when copious spare time surfaces, I think, from Michael.
Yeah.
And at that point, we'll run working group adoption on it.
Let's plan on this for Prague.
Oh, that's where we're going after Chicago.
Yes, it's Prague, I think.
The Prague. Yeah, that sounds like a reasonable time. And there's enough changes here that it really should be a BIS as opposed to an update and corrections doc.
Yes.
Okay. How important is what's being done here to WebRTC? He says, not being sure he wants to know the answer.
Well, they use the UDP encapsulation.
Yes.
And the UDP encapsulation is implemented. It's out there. It's implemented. The draft change or the BIS changing doesn't affect the implementation at all.
Thank you. Hang on, you can make it. Okay. All right. Anybody have any questions or comments on the SCTP piece of the agenda? All right. I get to try to impersonate Joe Touch. Let's see if I can do that. So Joe's been working on this draft for a while. I believe it's been presented here in TSVWG in the past. This is about option space for UDP, and it's being done by taking advantage of the fact in the UDP packet, there are two links which currently are supposed to match, namely the IP and UDP links are both supposed to describe the same packet. It is possible to adjust them so they don't. And there's a little bit of IP packet hiding behind the end of the UDP payload. And what Joe is looking at here is to, in essence, use that as some UDP option space. It appears to work with implementations. There's a bunch of stuff down at the bottom indicating the kinds of things one might use UDP options for. Okay, new version of this coming soon. Interesting idea of hiding UDP option down there that'll make UDP behave like UDP Lite, but use the UDP port. That's been use the UDP protocol number. That's been the major obstacle to UDP Lite deployment, that it does not use the same protocol number as UDP. He's got some implementation code, and there's a request for the working group to pick this up as a draft. I'm a little cautious about this one. How many people have read this draft or read the 03 version? I think the 04 is waiting. Raise your hand if you've read this draft. I see two people. That's not enough to run a hum in the room. We'll take care of this on the list. And I think Lars is coming. Maybe tell us it's a bad idea, or
No, actually, Lysager, so I haven't really paid much attention to this. Has any data been shown about how well it works on the internet? Any measurement data? Because if it actually did work widely, I think that would be very cool and would be a pretty strong argument for taking it.
Please ask that question on the list,
Okay.
because Joe put on the slide, and all I can do is read his words, compatible with legacy so far. So clearly he's got some
Right.
running code that does something in some environment, but that's not the answer to the question you asked.
Right. Okay. Thank you.
All right. Any other questions? Mirja.
Yeah, cool event. I find the UDP Lite use case pretty interesting, actually. I would like to know or like to hear if anybody's interested in actually adopting that and using it.
Speaking as an individual with scars from UDP encapsulation and checksum nonsense, if this provides a better solution to people who don't like the UDP checksum because it's not a trailer, but would like to be able to actually checksum a few things that they care about, like, oh, say the port numbers and the UDP header, and use the UDP protocol number, as an individual, this could be quite useful. Anybody else want to comment on that? More discussion on the list, I hope. Okay. And Vincent.
Yes.
Thank you.
Just check. Oh, working very well. Hello. Hello, everybody. So I'm Vincent, and I will introduce you the update of this document I already presented at Berlin meeting. So this is FactFrame version 2, and the goal is to add support for convolutional FFC codes to this FAC framework. Just to point out the fact that we didn't try to patent anything in this document. Okay, so this is a reminder of FactFrame and what we are proposing. Very compact reminder. So this is a follow-up of RFC 62363 that was published in 2011 by myself, Ali, and Mark Watson. FactFrame is in fact more a shim layer than a protocol, which means that it fits between RTP and UDP most of the time. And the goal is to enable robust and scalable communications of content, and particularly real-time contents. So we assume here that there are many people interested by the same content at the same time, which makes it meaningful to use multicast and broadcast communications. That's the goal of this FactFrame. It's already included in 3PP MBMS, so multimedia, broadcast, and multicast services, and we start to have some deployment experience. The issue is that FactFrame requires that you are using block FFC codes, which turns out to be a little bit inefficient in terms of latency. It adds significant latency to all the participants all the time. And this issue can be really solved, totally solved almost, by using convolutional FFC codes that works differently. In very good reception conditions, receiver will not experience any latency from this point of view. When I say latency, I mean FAC-related latency. Of course, that has nothing to do with the communication latency, which is a different problem. But no latency from the FAC point of view. And in bad reception conditions, you still have a very slow, smaller latency compared to that of block codes. So the goal of FactFrame version 2 is just to add convolution code support to this specification. The differences with the previous version that I presented in Berlin are the following. We had an implementation status section as suggested by RFC 7942. So just to tell you what's going on from this point of view, we already have an implementation of FactFrame version 1. So which is commercial, for which we start to have some interoperability experience and deployments. And I am currently implementing FakeFrame version 2 based on this existing source code. So that's it. Then we also added an additional section at the end of the document that explains what are the differences between this version and the RFC 6363. And we fix a few mistakes in the document, but nothing very important. I wouldn't like to go into the details, but just highlight one point. So we also made progress in terms of block versus convolutional evaluation. What are the performance we can expect? And the message is that, honestly speaking, I don't understand why this work has not been done before, because there is really a big improvement in terms of latency by using convolution fed code. It really makes sense to do that. So you have the details in this paper that is referenced at the bottom of this slide. If ever you want, we can discuss this offline, sorry, whenever you want. There's no problem. Then I have a question for this group, and I would like to get your feedback on this point. The question is the following: should we continue calling this version 2, or should we just say that, well, this is an update of RFC 6363 that would be obsoleted? So some background information to make you, so that you understand the situation. In this version, we do not remove anything. We just have one additional capability, being able to use convolutional codes. That's the first point. The second point is that we do not change anything in the way a receiver can decide to join or not to join the session. The receiver just has to retrieve the SDP session description file and have a look at it. Have a look at the fake encoding ID that identifies the fake scheme, and if this is a fake scheme that does not support, that this receiver does not support, then it just have to say, oh no, I don't want, I cannot, and then it issues another session, for instance. This is exactly the same mechanism, regardless of whether you are using block codes or convolutional codes. No change from this point of view either. Third point, this is probably the most important one. There is no version number in FakeFrame. FakeFrame, in fact, is not really a protocol. As I said, it's more a shim layer. There is no FakeFrame either per se. There are headers and trailers, but those are related to the fake schemes and not to FakeFrame. So I think it is an important point. The only benefit I see in having this version 2 is that, okay, it makes it clear that we do support additional fake schemes. From the implementation point of view, it also highlights the fact that, okay, this is something different. In fact, when you try to implement both version 1 and version 2, you will see that there's a big difference in implementing convolution code support. I'm not speaking here about the fake scheme itself, which is something different, but just the way you have to manage packets, the way you have to manage symbols, data management, all those aspects are more complex with this version 2. So this is the main benefit I see in having this version 2 tag to this work. So if you have some opinion on what to do, version 2 versus an evolution of an existing RFC, then let us know. We would appreciate. No, nothing special. Okay, let's.
I can ask a few questions from here.
Yeah.
Okay. What do you change in RFC 6363? Are the pieces of RFC 6363 that have to change in order to implement this work?
Yes, we change all the mentions that were very specific to block codes. So, for instance, if in RFC 6363 the text mentions that, okay, we accumulate a certain number of source packets and then we create a block codes and then we do FEC encoding, to make it simple, then we change that into the following way. So we say that in case of block codes, then we accumulate blah, 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 the same text. But in case of convolutional codes, then we do something else. This is basically the main difference in between RFC 6363 and what we are proposing. And we do that throughout the document whenever this is required. So we add something else, we don't remove anything.
Okay. So what causes implementation differences that you described? It sounds like the 6363 protocol is kept intact. You simply changed the way the compression codes work so that you can get stuff out of them faster, courtesy of using convolution codes instead of block codes.
Yes, yes. We do not remove anything. So if you use fake frame version 2 in the traditional way with block codes, it won't make any change to the receiver. They won't notice anything. There's absolutely nothing new here. But you have this capability of using something else, of using different FC codes.
And
in fact, fake frame is agnostic, is more or less agnostic with respect to the codes you are using. We are so far in RFC 6363, you can use maybe 5 different block FC codes. A receiver will not necessarily support all of them. What we are proposing is just adding some more FC codes that work differently to this list.
This sounds like an extension and update, 'cause I think what you just said is that if I take a version 2 sender and try to interoperate with a version 1 6363 receiver, the receiver sees a bunch of codes advertised, some which it supports and some which it simply doesn't recognize, and it picks one that it supports, and everybody falls back to using one of the block codes.
Yes, if you want to have backward compatibility and if you are version 2 sender, then you should. I think the best solution is to have 2 different sessions, one with block codes, one's convolutional codes, and let it do. It's not a big overhead in terms of network communications because we are addressing, a single flow addresses tens of thousands of receivers. It's not a big deal from this point of view, and it's easy to fix for this.
We should look at it on the list, but based on what you've described, what I think I'm hearing sounds like an extension to 6363,
Yep.
and oh, by the way, there's some language in there that didn't anticipate convolution codes that requires some what are effectively editorial substitutions to avoid saying things that aren't true about convolution codes.
Okay, so by extension, you mean do not add this notion of version 2, but just continue as a fake frame.
If I send, what's the difference in receiver behavior if I say version 2 but only advertise the block codes in the setup?
Sorry, I didn't catch.
Okay, sender sends the setup code info to the receiver and says, "Hi, I want to speak version 2, and here are the codes I support, but lists only the block codes in 6363."
Yep.
Does a version 2 tag have any effect on the receiver's behavior?
No, absolutely no effect.
Okay, then I'm pretty sure you've got an extension. It'll have to be an update because there is text that doesn't apply to the convolution codes, but this sounds like we ought to be talking about this as an extension to 6363 because those are all really good backwards compatibility answers.
Yeah, okay, so we will get rid of this version 2 notion.
Okay.
Good, thank you. And okay. Oh. Doesn't work.
Here, hang on. There you go.
Okay, so next step. Well, I don't expect any major change in this document anymore. I think it's now quite stable. My first to-do item is to finish this implementation. Hopefully that will be done for next IETF. And just want to be sure that we do not miss anything important. But, well, I've already implemented the sender side. Now I have to finalize the receiver side. I think I'm okay, but I will be more confident when it's working very well. That's my first point. And second point, it makes no sense to have a fake framework if we don't have any fake scheme to put in it. I mean convolutional fake scheme. So what I'm proposing here is to specify this very basic conversion fake scheme called RLC, random linear codes. It's pretty simple to explain. I can explain it to you in 2 minutes. You will understand there's nothing complex in it. And so we have to specify the code details, but well, it's not a big deal. The signaling aspects, well, we already implemented it, so I guess it will be okay like that. I also have some experience from this point of view. And then we have to ask for INR registration for the new fake and ID. So that's anyway. This is the way our implementation works for the moment. This is the basic solution, basic scheme that we're using in our implementation. That's it.
Okay, from a process standpoint, what would you like the working group to do when? And I'll give you a straw man. We go. I'll give you a straw person proposal. We can start from there. Which is, sounds like you've got some implementation work to do, and you need to write up the to-do 2 on this slide. So you'll have a draft, and so sounds like the next meeting cycle you're likely to have a draft or 2 that we can look at adopting at that point.
Yes, for next meeting, I think it makes sense
Okay.
to add this working group item adoption if there is interest. Yeah. I can also mention that I'm keeping the network coding research group aware of this work. In fact, this work has been initiated there, and so there are more people there aware of this and who might read and comment on this.
Lars, so are there other people implementing this? So will there be an independent implementation from somebody?
As far as I know, no, not yet.
Okay, so that would be, so this is a sort of a general comment that I always make for these more specialized things, because if the authors also implement the code, it's great that you're doing this, but and it's better than not doing it, but it would be even better if somebody else would read the document and try to implement it in their code base, right?
Sure.
And because otherwise, if you guys are the only people implementing it, why do we need a standard? And
yes, especially as it is not open source implementation. So I do understand this. Yes, sure. There are implementations, interoperable implementations for fake frame, sure, but not yet. I would say this one, this extension.
Okay.
Just a Jabber comment. David may be about to ask the question, but Gory is interested in how many people in the room have read the draft.
That's certainly, how many, okay, let's go find out. How many people have read the draft? Raise your hand. I don't see any hands raised. Any hands raised in the Jabber room?
It's an impressive draft.
Sure
because IFC 6363 is quite impressive. It's quite long. It's maybe 60 or 70 pages long. And we had a few more, 5 pages more, perhaps 5, 6.
I might suggest you button up some people in the halls. I'm sorry.
Well, yes, I would just like, if you do the diff and if you look at the diff between IFC 6363 and this document, it's not that long.
Right. So
what I would suggest.
A couple of suggestions. One is to buttonhole some people in the hall to read the draft. And the second is, if this turns into an update, you don't need to reproduce all the 6363 text. You need to write the text on the new convolution codes and then explain what has to change in 6363 to allow them. You don't have to completely replace all the text in 6363 and obsolete it.
Yes.
So what will happen is when you're done, 6363 remains an adopted RFC, and then you have this additional draft that says, here's how to do convolution codes with 6363, and oh, by the way, some of the text in 6363 gets changed as follows to allow convolution codes to work.
Okay, so the appendix that we added that explains differences would be sufficient for that?
It's probably a good starting point. In essence, the difference is, opposed to writing a 6363 BIS that completely replaces that RFC, you write what is in effect a companion document that is read with 6363 to tell you how to start with 6363 and get convolution codes in addition to block codes.
Okay.
And I just had structure. Among other things, it's likely to result in a much shorter draft. Maybe we can get more people to read it.
Okay. Thank you.
Okay. Any other business? I think we're done. I believe TSV area meets this afternoon. Is that correct?
Yes, it is.
And so you can bring general transport questions to the TSV area meeting. Thank you very much, everybody. We're done. Let's see. Let's see. All righty. Yeah, and Vincent and Maxime, could you please please email me the notes you took? Good news is this session is going to be fairly easy to summarize. And Tim, thank you for describing Jabber. All right.